Hello, future 2 crore package holders. So today we're going to discuss the lead code problem of the day, which is maximum frequency stack and is labeled a hard problem on lead code. And it is a good problem because if you see the like to dislike ratio, it's very good. So thumbs up, try and solve it, right? And if you're not able to do it, I'll explain the question to you first. So what they are asking us is to design a stack-like data structure to push elements, and the only catch here is that when you pop the elements you have to pop the most frequent element from the stack. So one thing is that if you're asked, like the question says stack, but you don't necessarily have to use stack. तुम कुछ और भी use कर सकते हो. Like this question can also be solved using a priority queue, but the stack one seems more understandable, so I'm going with that, right? So I'll explain with examples. So the first example is okay. So we have 5 7, 5 7, and 4 5. So I'll walk through the code and explain the example line by line. So see, we're maintaining two maps. The first one is a frequency map. So basically the first integer value would be the value. So if it's a 5, it's a 5. And the second one would be frequency of that value. So how many times that element has occurred. And the trick here that we're gonna use, the magic happens here, is that here we have a map of integer and a stack. So this integer is the frequency of the element, and this stack is the value of the element. So what happens is, see, I'll explain to you. So let's say this is our frequency map, and this is our frequency stack wala map, right? So first you get a 5 and its value is 1. So in the frequency stack, for the value 1, you push the element 5, right? So you see this part and this part is the same, and while we're traversing we keep track of the maximum frequency that we have encountered so far. So for right now it's just 1. I'll call it n. Next you get a 7. 7 is also 1, so you push it on a stack. So basically this part is a stack, right? This part is a stack, and this part, the key, is an integer. Now you get a 5 again. 5 becomes equal to 2. So for 2, you'll push a 5 on the stack. Then you get a 7. 7 becomes 2 again. So for 2, you'll push a 7. Then you get a 4. 4 is 1, so you'll push it 1. Right? And here also you'll update. So frequency of 4 is 1. Then you get a 5. So 5 becomes equal to 3. So you'll create another key with 3 and push 5. So I'll write down the second frequency stack map that we have. So one is 5, 7, and 4. 2 is 5 and 7, and 3 is just 5. And this is our maximum frequency. So whenever we are asked to pop, so we have to return the maximum frequency element, which in our case is 5 right now, right? So what we do is, for this map, the key would be the maximum value, maximum frequency, and the value which will return is the top of the stack, so which is 5. So if a pop is called, return 5 and remove it. So now for 3, the stack has become empty. Stack becoming empty means that there's no more keys, there's no more elements with the frequency 3 or more. So now basically our maximum frequency becomes 2, right? Now we'll again, if pop is called, we'll pop 7, remove it, pop 5, remove it, stack becomes empty. So go back, pop 4, remove it, pop 7, remove it, right? So it depends on the number of pops of which are called. So I'll explain the code. So in the frequency stack, we initialize the maximum frequency to be 0. And when we're pushing an element, first what we do is frequency for that value increases. And for this frequency, we're using that as a key and pushing the value onto its corresponding stack, right? And then we also keep track. So if the frequency is greater than the maximum frequency, we update the maximum frequency. Now while popping, what we do is for the frequency stacks maximum frequency which we are keeping a track of, the top element is the one which we have to return from the pop function. So we keep that in the current variable, right? Then the frequency stack, then we pop it off basically. So this element itself will pop it off because we've used it and decrease its frequency. Now we check if the stack has become empty, then the maximum frequency also decreases and you return the current element.